So first of all, we're going to talk about the difference between these two words, verify and prove. When we verify, that's often what you do at the end of a question where you re-plug in your answer to see if it works or not. So that's all a verify question is verifying the identity, A and B, for theta equals 30 degrees means plug in 30 degrees and see if it works. And it's very similar to a proof. So we're going to do the verify part first. Verify theta equals 30 degrees. You split your page up just like a proof to have a left side and a right side. On the left side, you write what you have but plug in your answer. And on the right side, you do the same thing. And just like a proof, you can't move things from one side to the other, because we want to see if these things are the same. And it becomes a pie plate question. Now, the nice thing about this question is when this is on your next test, you'll be able to use your pie plates, okay? Make sure that we have the right values on them. I wasn't very careful. I didn't really carefully look for accuracy, so I was the benefit of the doubt. I did find one person who had a mistake for sure on their pie plate. So you can use your pie plate and say, I know what cos of 30 is. My pie plate tells me that is root 3 over 2. That means secant of 30 is 2 over root 3. And our job at this moment is to make these look the same. And you can choose whatever math techniques you'd like. Looking at this one, I feel like I would like to distribute this. If I distribute that, you see that you would get 2 over root 3 plus 2 root 3 over 2 root 3. Because how do you multiply fractions? You multiply the tops, you multiply the bottoms. And that is just 2 root 3 plus 1. Therefore, left side equals right side. And we've verified it. What does verifying do? It tells us that we are only certain that it works for 30. Verifying is somewhat weak. Proving is very strong. And so in this unit, you will find I tend to not ask a lot of verifying questions, because if you can prove, proving means it works for 30, it works for 45, it works for 80, it works for 72.895. It works for every number. That's how powerful a proof is. If you can prove something is always true, you never have to verify anything, because you can just say, I proved it. It's true. So in this question, what does a proof look like? Well, here's the original question, secant theta 1 plus cos theta on the left side, and the right side was 1 plus secant theta. What would I do to prove this one? I would probably say, let's use our, if you remember the main strategy? The main strategy that we came up with the other day for proofs? Change everything you can to either sine or cosine and write it as a single fraction. So on the left-hand side, can you see that you could change secant to 1 over cos? And on the right-hand side, you could change that secant to 1 over cos. I could then distribute 1 over cos times 1 is 1 over cos. 1 over cos times cos, again, you can think of that as cos over 1. Can you see that that would all cancel out? You just get 1. And I don't even have to do the second part of the strategy. The second part of the strategy was write as a single fraction. But they're already the same. So if they're already the same, why do any more work? We can just say left side equals right side, add a little bit of Latin. Woo! And we're done. I had one student once, I felt bad. I had one student say at the end, because I like having fun with the QED, I make it a little bit different each time. They were like, how do I know which QED to write? Because I was making them all fancy. I'm like, oh no, it doesn't matter. I'm kind of scared that you asked that question. So if you were wondering which QED do you, no, I'm just having fun making the letters different. Yeah, and this fancy D. You like that? I like that. It makes me happy. Okay. So for part B, if we prove it, this is B, if we prove it, we actually don't even have to verify. Does that make sense? So you should be able to know how to verify. You might get a verify question in the homework or in the quiz, and you should know how to work with numbers to make them the same. But for part B, we're just going to prove. And in our proof, okay, whoa, I like this one. This one is going to introduce to us into a new strategy. Now, the strategy of changing to sine and cos is great, and it works, and writing it as a single fraction is great. And I'm going to do this one with that strategy next. But I'm going to introduce you to a new strategy here that might be a little bit quicker, okay? And the new strategy looks like this. If there's a way that your left side and your right side have the same trig function, like, can you see the right side's all cotangent, the left side's all tangent. I can change things to sine and cos, perfectly okay, but if I see that there's something I could do that changes both sides to have the same one, that might be faster. So I look at this and I say, could I change cotangent to tan? Could I change tan to cotangent? Yes. Which one am I going to change? If I change the cotangent to tan, I'm going to have a lot of fractions inside of fractions. If I change the tan to cotangent, I don't have as many fractions. So I'm going to start with that. I'm going to change tangent to 1 over cotangent. Then the right-hand side is already a single fraction. The left-hand side is not. Right? This is 1 over 1. How do I add and subtract fractions? I need a common denominator. So I'm going to multiply the top by cotangent and the bottom by cotangent to get common denominator. Once I have that common denominator, I would get cotangent theta minus 1 over cotangent theta. And I look at the other side, but then they're the same, so we're done. Very, very nice. How long was that proof? Not very long. I just introduced you to a new strategy, and that strategy worked really well in this case. If you had changed cotangent to 1 over tangent, it would have also worked, but would have been a little bit longer because you had fractions inside of fractions. But you have to remember the other day we made notes that said when we have fractions inside of fractions, we like to get a single fraction in our numerator, a single fraction in our denominator, and then we can multiply by the reciprocal. Okay? Now, how many of you sometimes find out that you're like, oh, the teacher showed me a new way of doing it, but I forgot, and I did the other way, and I chose the longer way? You sometimes do that? So let's say you got to this proof, And you're like, ooh, I'll change everything to sine and cos. Not wrong, it's just going to be a little bit longer. Watch what happens. Tan is sine theta over cos theta. Cotangent, cos theta over sine theta, minus 1 over cos theta over sine. And how I'm going to use that same strategy, can I get a single fraction on both sides? On this one, I need to have a common denominator. So I need to multiply by cos theta over cos theta. And then I would get cos theta minus sine theta all over cos theta. And that is a single fraction. On the right-hand side, I have fractions inside of fractions. So I need to get a single fraction in the top, which means I need to multiply this one by sine theta over sine theta. And that would give me cos theta minus sine theta over sine theta on the top of my fraction. And on the bottom, I have cos theta over sine theta. And this is where your proofs can get lost. You have to be careful. So I try to leave a little bit of space in between. I try to make my main fraction line longer or thicker or something so I don't get mixed up and be like something from the previous part mixes into my new part. Because each time that you write something, you want to make sure that it's the same. Fractions inside. Now we have a single fraction on the top, single fraction on the bottom. The rule for fraction divided by a fraction, multiply by the reciprocal. So there's my top fraction. Multiplied by the reciprocal. This is grouped together. You might notice those are identical factors, so they will simplify. So before I multiply things out, I look for simplification. It does simplify, so now I'm just left with cos theta minus sine theta on the top of my fraction and cos of theta on the bottom of my fraction. I look at the other side. Once I got them both to be single fractions, they're the same. This was a lot longer than changing to cotangent, but it's still 100% full marks. So it doesn't matter whether you use a longer method or a shorter method. Sometimes I've solved a proof and it took a long time and I'm like, there's got to be a shorter way. So sometimes it's a puzzle to do it again, try a new technique to see if it would be shorter. But anyways, you would get it the same. Left side equals right side. Where do I get one of those pens for the test?